Okay, and in talking about equation solving, we need to be aware of this very important property of equality. This is kind of like the golden rule of algebra. And it says that whatever you do to one side of the equation, you have to do to the other. And sometimes it's written like this: if two things are equal, if A is equal to B, then A plus C is equal to B plus C. This is just saying like I can add C to both sides. Or I can subtract C from both sides. Or I can multiply both sides by the same number. Or I can divide both sides by the same number. And this makes a lot of sense if you're familiar with, like a football game and the score is 7-7, right? So it's a tie score. So these two scores are equal to each other. Now, if one team scores a touchdown, so that's usually 7 points, right? If they score the extra point, then their score goes up to 14. So what does this team have to do to keep the scores equal? Well, it's obvious that they would also have to add 7 to their score, so they would add the exact same amount. They need to score a touchdown as well so that they keep their scores tied or equal. And you could make arguments for all the other ones. You could say, what if one team lost 3 points? Well, the other team has to also lose 3 points to keep their scores equal. Or if one team doubles their points or one team triples their points, the other team would also have to triple their points. Or they cut their score in half, and then the other team has to cut their score in half. So it makes sense that whatever you do to one side, you have to do the other if things are to remain equal. Now let's kind of look at this with a visual representation. And by the way, I don't get any money for this, but I think this game on the iPad and Android called Dragon Box is really awesome. So check that out. It's a kind of game that does this sort of thing, but it's on a graphical interface and a lot of fun if you have an Android or iOS. So what that kind of does and this here is going to do is I want to find out what is the value of one of these things, right? This is like a box. And I want to find out what is the value of this. Um, and it's giving me, two kind of things that are equal. This side is equal to that side. So how many of these individual ones is that equal to? Well, all I have to do is, so red is negative and blue is positive. So I'm going to add 2 to both sides, right? This is um, what the property of equality says. So if I add 2 to both sides, now a blue cancels out with a red, so 1 minus 1 is 0. So this just goes away, and this goes away. So now I have these 6 boxes equal 6 individual ones. So what I do is then I say, okay, I'm going to divide both sides up into an equal amount. So this would be 1, 2, 3, 4, 5, 6. So there's 6 equal parts here and 6 equal parts here. So it's dividing evenly. And so each individual one box is equal to 1. So what was my original equation? I had 6 of these minus 2 was equal to, wait, I had 4, I think. Yeah. Okay, so what I do is I replace all of these with a 1. Is that right? Yeah, if I replace all of these with a 1, so there's 4, 5, 6, and then this is how I kind of check my answer is 2 of these cancel out with 2 of these, and then 4 equals 4 is true. Okay, let's do another one. How about, what if I had 3x equals 6? So here I just divide this up into 3 equal parts and divide this up into 3 equal parts. So 1, 2, 3. So each part's equal to 2. So here 3x is equal to 6 means that x is equal to 2. Or if I have something like this. Okay, what if I add 4 to both sides? I ran out of things, so I'm going to add 4. So 4 cancels out with those 4, and I'm going to add 4 to this side. And now I divide this up into 3 equal parts. 1, 1, 1. Oh, but here, now I ran into a problem, right? So I have this 1 left over, I need to divide it evenly. So if I divide it evenly into 3 parts, it would be 1/3 goes into each one. So the answer here would be x equals 3 and 1/3. So it's kind of a visual representation of how this property of equality works. And you could use them in balance scales. A lot of people like to do it this way. If you have, like 2 bags, these are bags, and maybe we'll have like 3 coins, and then over here you have like 15 coins or something, and just pretend that's 15. So what you do, and say it's balanced, so that means the weight of this is equal to the weight of that. So if I take off 3 coins, right? If I took off 3 coins, then this would be lighter than that, and it would tip, right? So I have to take 3 coins off of this. So I take 15 minus 3 would be 12. So I take off 3, throw them away. So now I have 12. And then since there's 2 bags, if I divide it evenly, the 12, that means each bag probably has 6 in it, right? Right. So that's the way you can figure it out in a sort of visual way.